You are literally on the path to a big tree. You are going to become a tree of knowledge. This course, or these videos and assessment, have been specifically designed for NMU RBA1002 Business Accounting. These videos and the assessments thereon are going to help you pass or improve your mark, help you get a distinction. But these videos don't replace your RBA notes and exercises. In order to be good at maths, you need to practice. And the more you practice, the better you will be at completing these sums and calculations. So let's start here. We've got Algebra in Learning Unit 1. Algebraic equations are mathematical statements that show two expressions are equal by using the equal sign between the two expressions. Algebraic equations include variables. Here are examples. You got 3z plus 5 is equal to 11. So on the left-hand side of the equal sign, you have an expression, a mathematical expression. On the right-hand side, 11 is also a mathematical expression. And what makes it an equation is the equal sign in between the two expressions. And then what makes it an algebraic equation is, in this case, the z. Z is the variable or the unknown. And this is a statement. A statement needs to either be true or false to be a mathematical statement. Like I said, these video lessons are created to explain the content clearly and guide you on the right path to becoming a tree of knowledge, but they do not replace your textbook. But these videos will definitely help you understand RBA 1002. And you will laugh your way through this course. A lot of this course is actually revision from high school maths. So you're on literally a path to a big tree. You're going to become a tree of knowledge. There we go. Don't be tempted to go off track. Stay on the path, stay focused. It's one semester and then you get a break. A mathematical expression is a statement made up of numbers, variables, and operations that shows a value but does not state that two things are equal. So a little bit of repetition from what I've just said. Here are examples of a mathematical expression: 3 plus 7, 2x minus 5, 4 multiplied by a plus b in brackets. Those are examples of mathematical expressions. They're not equations because there's no equal sign connecting the expressions. So this is just a little bit of theory before we get on to calculations. A mathematical statement is a sentence in maths that is either true or false. And examples of mathematical statements: 5 plus 3 is equal to 8. You can do the maths in your head. That is a true statement, a true mathematical statement. 10 is not less than 4, so that statement is false. All even numbers are divisible by 2, that is true. So these are examples of mathematical statements. Now most of this unit is about algebraic equations. So algebraic equations are mathematical statements that show two expressions are equal. And this here is an example of a linear or a straight line equation. We will do straight line graphs later in the course. For now, we're calculating algebraic equations, solving for x, solving for the unknown. There are a number of rules that apply in order to do these calculations. As we practice in the next video, we will practice these rules, but let's have a look at what the rules are. Just what you see in front of you is rule 1. The number of the rule doesn't really matter. We're just going through the rules and some basic maths rules that you will need in order to do algebraic equations. There's a rule, just so you know, going forward. This rule is in English, isiXhosa, isiZulu, and Setswana. So you can have a look if you speak one of these languages. But what I do suggest, the tests and exams are in English. So know the English, but to help your understanding, you can see your language of preference. So rule number 1, whatever operation you perform, operation plus, minus, divide, multiply, on the one side of the equation, you must perform on the other side. For example, if you subtract 4 on the left-hand side, you must do the same to the right-hand side. I will show you examples of that. Let's have a look. For example, 3x plus 7 is equal to 22. Now, if I subtract 4 on the left-hand side, I must do the same on the right-hand side. And then this equation will still be equal. So rule number 1, what I do to the left-hand side, I must do to the right-hand side. Rule number 2, if a term changes sides, the sign must change. So if you go from a positive on the left-hand side and you move the term to the right-hand side, it becomes a negative. A negative from the left-hand side to the right-hand side becomes a positive. It can also move from the right-hand side to the left-hand side. So if you cross the equal sign in the middle of the equation, the sign will change. Multiply becomes divide. Divide becomes multiply. In other words, when you move a term to the other side of the equation, you must reverse the operation in front of it. You could say, instead of reverse, you must put the opposite sign in front of the term if the term crosses the equal sign. A plus, and the opposite of addition is subtraction. The opposite of multiplication is division. That is rule number 2. There you have rule number 2 in isiXhosa. If you want to read that carefully, you can pause the video. Rule number 2 in isiZulu, the language of Zulu, and rule number 3, the language of Tswane. I'm not sure if I pronounced that correctly. You can correct me when I see you in class. So there we go. Rule number 2 in a few languages. Here is another example. We've got 3x plus 7 is equal to 22. We're heading towards solving for x, so we want to get the unknown variable on its own. But to explain the rule I've just mentioned, plus 7, to take it to the right-hand side, it changes to negative 7. That is an example of an algebraic equation rule, a math rule. There we go. If you take the 7 to the right-hand side, it goes from a positive 7 to a negative 7. 3x minus 2, if I take the minus 2 to the right-hand side, it will become plus 2. There we go. So when an operation crosses the equal sign, you will get the opposite operation. Minus becomes a plus, and a plus becomes a minus. Multiply becomes divide, and divide becomes multiply. Rule number 3, an equation stays balanced. The left-hand side is equal to the right-hand side if you multiply both sides by the same non-zero number. Let's have a look when we would do that. Once again, different languages there. If you want to read your language, pause the video. For example, x over 5 is equal to 4. I want to get x on its own, so I can multiply x over 5 by 5. But what I do to the left-hand side, I must do to the right-hand side. So this rule says you can multiply the left-hand side by a non-zero number. The number cannot be naught, because if you multiply by naught, it becomes naught, and you won't be able to solve for x correctly. So let's see, if you multiply the left-hand side by 5, you must do the same to the right-hand side. And you will see that the 5's here will cancel out, and you can multiply 4 by 5 is equal to 20. So you cancel out the 5's, and if you multiply 4 by 5, that becomes 20. X is equal to 20. So there's an example of multiplying by a non-zero number to get x on its own. Rule number 4. An equation stays balanced if you divide both sides by the same non-zero number. This video is going a little bit long because it's an introduction to the unit. In the future, videos will be not longer than 15 minutes when we look at examples. Once again, there are the different languages to explain the rule. Let's look at an example. 7x is equal to 63. I want to get x, the unknown, the variable, on its own. So I say 7x divided by 7 is equal to 63 divided by 7. What I do to the left-hand side, I must do to the right-hand side. Therefore, x is equal to 9. This brings us to another rule. When an equation has brackets, we use the distributive law to open the brackets, take away the brackets, or factorize the brackets. We need to do that first so we can solve for x or solve for the unknown. We need to remove the brackets by using a math law called the distributive law. You're most probably more familiar with the actual math than the theory of the law. So let's have a look at an example. There we have an example. 4 multiplied by, in brackets, 5x minus 4, close your brackets, is equal to 24. Now what we need to do is use the distributive law to remove these brackets. Now how we do that is we multiply the 4 by each term inside the brackets. So 4 multiplied by 5x minus 4 multiplied by the 4 is equal to 24. Then if we carry on, 4 multiplied by 5x is 20x. 4 multiplied by 4 is 16, and the sign was minus. So 20x minus 16 is equal to 24. Then we take the 16 to the right-hand side, and it becomes plus 16. So we're left with 20x is equal to 40. And if we want to remove the 20, we can divide by 20, but what we do to the left-hand side, we must do to the right-hand side. So 20x is equal to 40. I've left that step out, but if we divide both sides by 20, we will get x is equal to 2. But the example that I wanted to show was the distributive law, which means you multiply the 4 by both terms inside the brackets to remove the brackets. Then you can carry on solving for the unknown. So there's another example of a method or law needed to solve for the unknown. And here is just something that is quite common, but when you solve for an algebraic equation or solve for x, you might need to use several rules in order to solve the equation. Your goal is, like it says here, to get x or the unknown on its own. Your goal is to isolate the variable. You want the unknown to stand alone on the one side of the equation. And that's what we got. Our final result, x is on its own, and x is equal to 2. Some more revision from your earlier maths days, and you might need to be reminded of these maths rules. And they are known as rules of negative numbers. They simply mean adding a negative number. So you adding a negative number, I will show you an example, is the same as subtracting a positive. Now that might sound a little bit confusing, but I will show you a few examples. Adding a negative number, 7 plus minus 3, it's the same as subtracting a positive number. So it's 7 minus 3. But we'll look at an example. Subtracting a negative number is the same as adding a positive. So 7 minus 3 is the same as saying 7 plus 3. Multiplying or dividing different signs results in a negative. 6 multiplied by minus 6 will result in a negative, minus 36. Multiplying or dividing the same signs results in a positive. Minus 6 multiplied by minus 6 is equal to 36, because a minus multiplied by a minus is a positive. So let's have a look at a few examples. Example 1, adding a negative number is the same as subtracting a positive number. 8 plus minus 3 is the same as saying 8 minus 3, because adding a negative number results in a negative. 8 plus minus 3 is equal to 8 minus 3 is equal to 5. Second example, remember a minus minus a minus becomes a plus. 7 minus, here is actually multiplied, minus 1 multiplied by minus 5. So minus minus becomes a plus. 7 plus 5 is equal to 12. Multiplying or dividing different signs results in a negative number. Plus 7 multiplied by minus 3 plus multiplied by a minus is a negative. 7 times by 3 is 21. So this is all revision. You would have come across this in your maths career somewhere along the line. A minus divided by a plus is a minus. 8 divided by 2 is equal to 4. Minus 8 divided by 2 is equal to minus 4. Another example, a negative multiplied by a negative, a minus multiplied by a minus becomes a plus. 6 times by 3 is 18. A minus divided by a minus becomes a plus. 10 divided by 2 is equal to 5. Right, BODMAS. Some revision on BODMAS. When you solve equations or mathematical expressions, we first do the brackets, do everything inside the brackets. Then we look at the orders. And what are orders? We're looking at square roots there, or numbers or constants with exponents. 2 is a constant, 2 to the power of 3, 3 is an exponent. So orders, exponents, and square roots or cube roots. Then we do division, then we do multiplication, addition, and subtraction. Just for the record, division and multiplication sit on the same level, and so does addition and subtraction. So we could say division and multiplication are done before addition and subtraction. When you are solving for an expression, for example, if you only have plus and minus in the expression, we work from left to right. Just some more information on what orders are. Orders are operations that involve powers, exponents, and roots. Examples include squaring a number, cubing a number, or finding square or cube roots. There's an example, 2 examples of orders. So when you solve an expression, this is the order you solve the expression in, and I think you have all heard of BODMAS. There's BODMAS in isiXhosa, BODMAS in isiZulu, BODMAS in Setswana. So let's have a quick example or look at an example. In this example, we've got 8 multiplied by, in brackets, 2 plus 4 divided by, in brackets, 7 plus 5. Yes, I wish I was on that plane going on an island trip. This is real stuff. Sometimes I get interruptions and I don't edit because it takes up too much time. So let's stay focused. We have here an example where we're going to use BODMAS. So BODMAS says brackets first. So if we have a look at this example, we got 2 plus 4 is equal to 6. 7 plus 5 is equal to 12. And we can take away these first brackets. And we are left with, still in brackets, 6 divided by 12. And 6 divided by 12 simplifies to a half. 8 times by half is equal to 4. So this example here was about doing the brackets first. And then we could solve this mathematical expression using BODMAS. Right, let's have a look at this example. We've been given, let me change color to red. We've been given this following expression. In brackets, we've got 15 minus 4 multiplied by 20. Tricky. Divided by minus 5 in brackets plus 5 multiplied by minus 2. This looks interesting and you have to be very careful. So let's solve what's inside this brackets. Now the rule says we must multiply before we subtract. So you first say 4 multiplied by 20 is 80. Now you have 15 minus 80 and you've applied BODMAS. You did multiplication first. Then we say divide by minus 5. I haven't got to that yet. Plus, there's a multiplication sign. I must do that before addition and subtraction. So 5 multiplied by minus 2 is minus 10. So what I've done is the multiplication first. 15 minus 80 divided by minus 5 plus minus 10. Then what I did was I solved for this bracket. 15 minus 80 is minus 65. Divide by minus 5, minus 10. A plus minus 10 results in a minus. So now what we need to do is division. I've removed most of the brackets. Division comes before subtraction. 65 minus 65 divided by minus 5. Minus divided by minus becomes a plus. 65 divided by 5 is 13. Minus the 10 becomes 3. So there we go. A tricky one. Remember, maths is practice. Once you know how to do the first one, you practice another 10. In your test, you will get most probably multiple choice questions. For example, this equation would have A as an answer 5, B as an answer 7, C3, D10. And you will have to do the calculation on a workings page and select the correct letter, which represents the correct answer. These questions will be multiple choice questions. Right, just to clear up a few questions on this topic. An algebraic equation. What are algebraic equations? Mathematical statements. Are algebraic equations mathematical statements? Yes, an algebraic equation is a mathematical statement because it makes a claim that the equation is either true or false. A mathematical statement must be either true or false. An algebraic equation is a mathematical statement. And there's an example. 3x plus 2 is equal to 11. And this statement, as it claims that this is a statement, as it claims that some value of x makes the two sides equal, and it'll either be true or false, which meets the definition of a mathematical statement, depending on the value of x. Just some theory for understanding. Does an equation always have a variable? No, because you get numerical equations, no variables, for example, x, y, z. There are equations, numerical equations, and you get algebraic equations. So numerical equations do not have variables. Algebraic equations do have variables, but they're both equations. These are the ones learners usually think of when they hear equation. So when you hear equations, an algebraic equation has a variable, and a normal simple numerical equation does not have a variable. But algebraic equations, we're looking at solving for x, y, z, solving for the unknown. Just to end off, wisdom comes with time. Work hard and become a tree of knowledge. I know this from experience. Greater knowledge gives you a better success chance in life. You might think the maths is not important. You might think doing accounting is not important. But I'm telling you, the more knowledge you gain over time, the better chance you have of success in life. You never know when you need some knowledge. The big tree in Tsutsukama that you were on the path to in the first slide is an Otaniqua yellowwood. It's over 1,000 years old, over 36 meters high, and it has a trunk with a circumference of over 7 meters. So you people are becoming a tree of knowledge. Choose your mentors and whom you follow wisely this semester, so you flourish over time and grow into a big tree of knowledge, figuratively speaking. All the best for the semester. There is a link to a quiz on this video which will help you cement the theory behind algebra. The next video we look at will concentrate on examples and practice using the rules that you have just learned. But you should do the quiz on this video. See you in the next video. Cheers. Bye.